The first piece of that vocabulary is this word, constant. What does the word constant mean in English? Not math class. Blake. Always. Always the same. For example, every day you come to math class, you look forward, you see a very good-looking individual. That is a constant in your life. Okay? Everybody understand? Okay. Jaswinder's a good-looking cat. What are you trying to say? Jadwinder is a good-looking cat. What are you trying to say?
I'm a dog. No, I said he was good-looking.
All right.
I was going to compliment the kid.
Yeah, okay. So, something that is always the same, yes?
Yes.
Okay. So in math class, that means we represent that with a number. As opposed to, what's x?
A variable.
A variable. Variable means it can change, yes?
Yes.
If I have variable moods, it means they change. Well, in math, a variable is an x. A constant is a number. Cool?
Yeah.
All right. So you guys already know this. We can use this. What would you do mathematically to solve that? Brackets first. So you do 5 times 24, which would be 120, yes? All right. Now, this diagram shows another way to do that. 5 by 20. Right? What does this mean when I put a 5 here? What does that mean for this distance?
Like 5 units.
It's in 5 chunks. Agreed? And what does this 20 mean for this direction? 20 chunks. So I have a group of 5 repeated 20 times to give me 100. Yes? And here I have a group of 5 repeated 4 times to give me 20 chunks. Yes? And that gives me 100 here plus 20 for a total of 120. This diagram shows that 5 times 20 plus 4 is the exact same thing as 5 times 20 plus 5 times 4. Does everybody see that?
Yes.
Great. We call this the distributive property because the coefficient, which in this case, there's a new word for some of you. The coefficient, in this case, 5, is distributed, and I'm going to highlight distributed, to all the others. Does everybody understand that?
Yes.
What is happening is, is this. 5 times 20 plus 4. 5 is going to 20, and then 5 is going to 4. Some of you will have seen this before. Some of you will have heard some cute little pet name for it. What it's really called is the distributive property. Okay? When you leave my class, you may have another teacher that calls it something like flying arrows or some other crap name. No, you're smart kids. You don't need lies. You can hear the truth. It's called the distributive property. Okay? Okay. Now, you guys are smart kids. If it works with numbers, what are numbers? Symbols to represent something real. Will this plan work with real things?
Yes.
Of course it will. And here is an example of it. To multiply this, I need to use algebra tiles. 2 times 4x. Well, I even told you how to do it. There's 4x. That's positive, correct?
Yes.
Could I write them vertically? Could I write them stacked 2 on top of each other? Yes, I could. There is one of them. How many do I need? 2 of them. Which gives me what? All you got to do is count. So 2 times 4x gives me 8x. Now you guys are smart kids. That's what's really happening, yes? How do we represent that in the math world? With 2 times 4. Cool? Why did x not change? Excellent. Everybody good? That's how easy it is. Believe it or not, people find this difficult. Here's the problem. As always, we start with something that's easy. And then most of your peers forget that if something works in math when it's easy, it still works in math when the numbers are difficult. I don't know why you guys are the only kids that can remember that. Yes, Sam? No. A constant is a number that stands by itself. A coefficient is a number that multiplies something else. Your coefficient can be a constant, but once it multiplies, the answer becomes the constant. Do you understand? This answer isn't. This answer is a coefficient in a variable because you don't know what x is. This is a coefficient, but your answer is a constant because there's nothing else 120 can be, because you can't get to 120 until you do your coefficient. Okay? Cool? All right. So, Amshuman. Of course. Find this product. Now remember, we have to do this once or twice with algebra tiles. But we're going to use our shortcut. What does this mean in English? It means 3 times the polynomial, right? So I got to draw the polynomial how many times? Thrice. The first one is this. 2 big guys, 2 shaded bars, 1 little guy, right? How many times do I got to draw that? Thrice. And the answer, of course, is 6 big guys, 2, 6 bars, and 3 little guys. Right? And the product would be 6b squared minus 6b plus 3. Good for grapes? Good for grapes. That's a band. They're from Surrey. They're really good. I highly recommend them. You guys do these. What do you sketch? The coefficient or the polynomial? Polynomial. 4p, 3 little guys. How many of them do I need? 3 of them. And what's my final answer? 12p plus minus 9. Technically, what is it, Lee? 12p plus minus 9. Technically. Well, how do we write it? 12p minus 9. What do I draw here? Draw 1 big guy, shaded, 1 bar, unshaded, 3 little guys, unshaded. How many times do I got to do that? Twice. 1, 2, 3. What's the answer? Negative 2s squared plus 2s plus 6. Everybody good?
Yeah.
Good. Forget about them till your quiz. Now let's do it properly. What does this 5 goes where? It distributes into the polynomial, right?
Yeah.
Many of you are good enough to do this in your head. Some of you will forget. So if you know yourselves, if you are not a details-oriented person, you may want to do this. Draw an arrow, write an answer. What is negative 5 times positive 4? Negative 20. Does the variable change?
No.
No. E squared. Draw an arrow, write an answer. Positive 25 what? E. Draw an arrow, write an answer. Negative 15. It's that easy. Okay, Josiah? Yes. Remember, this is thinking. Some people need it to remind themselves. Others don't. What do I have here? There and there. What's my answer? 21s squared plus 27. What's my answer here? Plus 32e. What about this one? Right? And finally, everybody good?
Yes.
I don't know why that's confusing, and yet it is. I can't explain it. I don't know why people have trouble with it. What about division? What does it mean when I say division? What am I doing in real life? That's one thing I'm doing, but I don't say, hey, I've got a pizza. Let's multiply it by a half and go. What do? No. Guys, you're not in math class. You're in real life. I have a pizza.
Cutting it.
Thank you. I am cutting it into equal pieces. Right?
Yes.
I have my pizza. I'm going to share it with Amy, Vicky, and Leighton. So what am I going to cut it into? No! I'm not giving you my pizza. I want some. Punk. How many? I'm cutting it into 4. That is what division is, isn't it? Cutting into equal pieces. Now, in reality, I paid for the pizza, so I'm taking more. Sorry. But if we all chipped in, we'd all get the same piece. Right?
Yeah.
Billy gives you $1.
Billy's a punk.
I'm Billy.
No, I just don't know why Billy would do that. He's getting some free pizza. I don't know why he's got to, here, have some money so I can have more. What a dink. So, this says I have, now this one, guys, we actually have to draw it out. How many ways can I split that up? Could I do this? Is that dividing into 2 equal pieces? Yeah. Could I do this?
Of course.
Yeah, that's dividing into 2 equal pieces. Could I do this? Stupid. Not stupid. Stupid.
Oh, yeah.
Oh, it's doing that thing again.
Bye. Yeah, you got that video.
Is it still there?
Yes.
No, it made everything disappear. That was useful. It's nice to have video evidence of money well spent. Nope. Why would they let me have the one back that worked when they could spend this kind of money to get me this one that doesn't?
There you go.
Could I do that?
Yes.
It's all the same thing. All I'm doing is cutting it into pieces. So, what does this mean?
That means
I take that picture and I cut it into 3 equal chunks, yes?
yes.
So, I got 6 bars. And again, like I say, when we're dividing, it's easier to draw it. 1, 2, 3, 4, 5, 6, and I'm betting most of you drew it something like that.
Yes.
Even if I hadn't been drawing it, you probably drew something like that.
Yes.
Why did you draw this way and then this way? Or better yet, did anybody draw? Yeah. Why did you draw it that way? Because I noticed a lot of people drawing while I was drawing without looking up. So you already had in your mind how you were going to draw this, didn't you?
Yeah.
Why? How many people drew exactly what I have here? Why? How were you able to do that and not watch what I was doing? What did you do? Why did you draw 6 this way and 9 this way? Jack.
It says in the 3 rows.
Into 3, right? So you set up 6 into 3, and you set up 9 into 3, didn't you? What did you get here when you did your splitting up? 2 bars and 3 little boxes, yes? So what's your answer? 2s minus 3. Now you guys have already done the next step. By drawing it this way, I just lost 2 of them, interesting. By drawing it this way, you already knew how to actually do this. You are not dividing this whole thing by 3. What are you really doing? You're dividing 6s into 3 and negative 9 into 3.
Ooh.
Understand?
Yep.
Sam?
If that's not the coefficient?
There is only one coefficient here. What is it? No. The 2, because the 2 is multiplying
Oh,
something.
yeah, I was thinking.
In this equation, what's the coefficient? 6 is a coefficient. 3 is a constant. Gouda?
Great.
Great. Now, of course, what does this really mean? I have 3 big guys, and I got to divide that into 3, which gives me 1, correct?
Yep.
And I got 12 bars, which I got to divide into 3, which gives me 4. So we're going to skip the drawing because I trust you guys. G squared plus 4 what? G. Because the bars have been split up. Yes?
Will we need to know drawing for the quiz as well?
Yep, at least once. 5, 6, 7, 8, 9, 10, 11, 12. Right?
Yep.
Divided into 3. What about this one? Negative 2b squared. 3. What about this one? S squared minus s
Plus 2.
and
Plus 2 minus 1.
everybody cool?
Yeah.
Now I let you guys skip a step because you're smart kids. When algebra tiles are not available, which is never, or always, I mean, we don't walk down the street with our pockets full of algebra tiles,
Sometimes.
right? Unless you're really a nerd. Or when the divisor is negative, we can use what we already know about division. So if I have 8x divided by 4, as I say right here, that's the divisor. That is the same as 8x over 4. Right? Yeah?
Yeah.
Okay. Now, what then is that simplified? 2x. Why? Because the 8 cuts in half.
Yeah.
Can I cut the x's in half?
No.
Why?
Because it's not
Because we don't know x's value. Behind my back, I have X amount of money. How much do each of you get?
$6.
X divided.
You have no idea, do you?
Yeah.
Because you don't know how much money is behind my back. I'm a teacher. I have no money. There's no money behind my back. So all of you get 0 divided by 28.
Which is 0.
0. Tell you what, tomorrow I'll triple your salary.
Gummy bears. Oh, that's a good.
See what I did there?
Still 0.
It's only funny when you explain it. Okay. So you guys are smart kids now, right? You're aware of why this works, right? You're also aware that without even thinking about it, you knew what you were doing here, didn't you? You were dividing each term by 3, yes?
Yes.
So, put all that together and do this. What is this really? Negative 9v squared over 3 and 6 over 3. What is this? Negative 3v squared. And what is this? 2. Done. Now, are you guys the type of grade 9 math class that needs to write that out the whole every time?
No.
No. You guys are the type of grade 9 class that can go, okay, that's negative 3v squared plus 2. Do you understand?
Yes.
This is what is really happening. Do you need to know this?
No. Maybe. Yes.
Yeah, you need to know what's really happening, don't you? But You're also smart enough to do division in your heads. Right?
Yeah.
What if it's a number you can't divide in your head? What? Yes. What if it was 144v squared plus 80 over 16? You'd go to your calculator. No, it would be 5. But that's okay. So, again, as always, how do we start? Easy. Because the rules don't change even when the numbers get gigantic. So what am I doing here? Really, what am I doing? 12r squared over 4 plus 8 over 4, which is what? 3r squared plus 2. Yeah? Yeah. What's this one? Really? 18v squared over 6 plus negative 6v over 6 plus 12 over 6. What's this? 3v squared. What's this? Minus v. Plus minus v. How do we really write it because we're lazy? Minus v and plus 2. What about this one? Negative 4e squared over 2 plus negative 8e over 2. What's that? 2e squared minus 4e. Sam. Of course. I should start charging you guys a nickel for bathroom runs. It would be amazing how few people needed to leave.
What's a nickel?
5 cents.
Who didn't know that?
Are you all good? Does it matter how big the numbers get? No. You follow the same rules. What if, don't turn your pages away yet, what if I have this?
Oh my goodness.
Dog, that is not true.
Of course you know the answer. What is it?
2x squared minus 1
2x squared
minus x
minus x
plus
6. What did that negative do? The same thing negatives do all the time.
They add up.
Change every sign. Right?
Yeah.
Everybody good?
Great. Oh no.
So now, I would like you guys to draw this out as a rule that always works. So remember, if we're doing a rule that always works, can that rule have any numbers in it? No, because once you put a number in it, it doesn't always work, does it?
Yeah.
So how would I do the two things we did today as a rule? We did multiply and we did divide. So I want those summarized into a rule. How would you draw that? I'll wait a minute for you guys to see if you can figure that out. So who would like to offer their multiply rule? Nobody? I'm hurt. No one?
I'm thinking.
Nobody? No one? Nobody at all? Okay. X A plus B
Oh.
becomes X times A plus X times B. And if you want to go really crazy, you would go dot, 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 Z, dot, 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 X, Z. Because the X multiplies by everything. What would it be for divide? A plus B dot, 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 Z over X is A over X plus B over X dot, 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 Z over X. Because the rules are all the same. That would be 1, wouldn't it? That would be X squared, wouldn't it? Everybody Gouda?
Yeah.
Good for grapes. Great band from Surya. Highly recommend them. Said that already.